One of the options you have when solving quadratic equations is to solve them by factoring. This is a nice, easy way to do it, so long as you understand how to factor, and it's also a very quick way of solving quadratics. In order to do that, you have to understand a fairly simple principle, and that principle is called the principle of zero products, and it's also referred to as the zero product property. And so this is the basic idea of the principle of zero products. If I give you this statement, you should be able to tell me something about A or B, because what we have is A times B, and that's going to be equal to 0. So what is it, that you can say about A and B, or A or B? Well, since the product of these two numbers gives you 0, you know that either A is equal to 0, or B is equal to 0, or maybe both A and B are equal to 0. And if you can get your head around that idea, once you have an equation factored down, you can take each of these factors and set it equal to 0 and solve simple equations. The first thing you want to do when solving quadratics by factoring is to get the equation set equal to 0. And what that means is that you get all of the terms on one side of the equation by adding and subtracting them. Now, it doesn't really matter if you add them or subtract them to the right or left side, but what you're trying to do is get it into this form. Now, personally, I always want my A to be positive, so I will go about manipulating the formula to make that happen. Now, if you feel comfortable factoring a polynomial when the first term is negative, then by all means go ahead and do that. But if you are uncomfortable doing that, and while you are adding and subtracting your terms, you notice that your A is negative, you are left with a very simple workaround. Okay? All of the rules that you've learned about solving equations are still true, and namely the one that says that you can multiply or divide by any number so long as you multiply and divide every single term by that same number. So if you end up and you get all the terms on one side of the equation, you have it set equal to 0, and you look down and A is negative and you don't like that, then go ahead and multiply every single term by -1, and that'll take care of everything for you. Once you've done that, then you can start factoring. And all of the factoring techniques that you have learned before are in play. You want to make sure that it's in descending order. Okay, you want to check to see if there is a common factor in all of the terms. You want to take that out if possible. Okay, then if there's 2 terms, maybe you check to see if it's a difference of squares. If there's 3 terms, maybe you have to do the A times C method. Okay, but whatever you have to do to get the non-zero side factored, that's what you got to do. Once you have it all factored, then you're going to take each factor that is not a constant and set that equal to 0. Now, what that means is, if you went and took out a greatest common factor of, let's say, 5, well, 5 by itself is a constant. Okay, so you're not going to take 5 and set it equal to 0. Only something with a variable are you going to set equal to 0. So if you took a 5x out, that would be fine. Set that equal to 0. Once you have all your factors, all your non-constant factors set equal to 0, you're going to have these real small, simple equations. Okay, and they're going to be 1 or 2 or maybe even no steps to get it solved from there. Okay, make sure that you have set it equal to 0 first. That's very, very important, because the principle of zero products does not work with any other number besides 0. So I'm just going to go through a few examples of this Again, if you don't know how to factor, this is you're going to be helpless during this part of the solving quadratic equations. But all I'm going to do is follow those 4 steps that we just went over. Okay, and the first step is to make sure all terms are on one side. So I'm going to subtract 6 from both sides, and I'm going to have x squared minus x minus 6 equals 0. Okay, now I'm going to go about factoring this trinomial over here. And you can use the a times c method, but since this first term a is 1, I'm going to kind of take a little shortcut here. We know that we have an x and an x. Now all we're doing is looking for numbers that multiply to give us -6 and add to give us -1. That would be -3 and +2. Okay, and you can do a quick check, right? X squared plus 2x minus 3x gives us -x, and then finally -6. So now we have our polynomial factored, and we're going to use the idea of this principle of zero products, and we're going to set each of our factors equal to 0. Okay, and then we're just going to solve both of these. Add 3 to both sides, you get x equals 3. That's one of your answers. And subtract 2 from both sides, and x equals -2. Now, just like any other equation, once you have what you think is a solution, you can just plug those back in and make sure that you get a true statement. Only do one at a time. So if we're checking whether or not 3 is really an answer, you plug it in here. 3 squared is 9, minus 3 is 6, so that one's good. Take -2 and square it, get +4, minus a -2 is also 6. All right, so here's another example of a quadratic equation. And again, you know it's quadratic because of the squared term. And also just something to keep in mind, this is also telling you how many potential answers you can get. Okay, so whatever the exponent is, whatever the biggest exponent is how many potential answers you can get. Okay, but we are going to use, solve this by factoring. And so we want to start off by subtracting the 10b on both sides. So we'd have 5b squared minus 10b equals 0. And now we want to go about factoring it. And what you should notice is, it is in descending order. So always check to see if there's a greatest common factor. And in this case there is. It's a 5b. We can take a 5b out of both of these. So we take the 5b out. We're left with b minus 2. That's as factored as it's going to get. So we're going to set both of our factors equal to 0. And we're going to solve these. So, you would start off by dividing by 5. 0 divided by 5 is just 0. So one of our answers is b equals 0. And then the second equation here, we're going to add 2 to both sides, and b equals 2. Again, if you want to plug these back into the original, it should work out just fine. For this example, we have the quadratic all on one side. It's already set equal to 0, so we can skip that step. And hopefully you notice that there is a greatest common factor that we have in this. It's a 2. Okay, and so, before when you're just factoring, you would take the 2 out and it would come along and be part of your answer. But all we're really worried about is the values of the x that when we plug in on this side give us 0. So it's kind of, maybe easier now because that 2 doesn't really make that big a difference. And so you could take the 2 out, and then, part of the steps said take each non-constant factor and set it equal to 0. And remember, 2 would be a constant. I think an easier way to think about this is that since this is an equation, because we have this equal sign, we are allowed to multiply or divide by any number we want, so long as every single term gets divided by that number. So instead of factoring out a 2, I'm just going to divide everything by 2. Okay, and then we'd have x squared minus 6x plus 9 equals 0. Now just be careful on what the problem is asking for. If you're asked to simplify a quadratic by factoring, that 2 is very important. If you're asked to solve an equation, you can do this step here. But now we have a trinomial, and we're going to factor it. Again, go through the a times c method if you want to, if that helps. Okay, but we're looking for numbers that multiply to give you positive 9, add to give you negative 6. Okay, and so in this case it's negative 3 and negative 3. We have it factored. We set both of our factors equal to 0 and solve. And in both cases, x is going to be 3. Okay, so a couple slides ago I mentioned how the exponent refers to the potential solutions. Okay, in this case it's just 3, we got it twice. Okay, and when we start graphing these, looking at the parabolas, we're going to notice that this parabola would only hit the x-axis at this point. So for the final example I'm going to do, we have this equation. And it's always worthwhile to kind of take a look at things before you get going. And if you were paying attention to what I was talking about earlier, you would know that the biggest exponent refers to the potential amount of solutions. So there's a possibility of 3 separate solutions to this equation, but we're still going to do it by factoring, and we still just follow those 4 steps. And the first one of those steps, again, is to get all of the non-zero terms on one side of the equation. Now I'm going to write this in descending order at the same time. So we have 3x cubed minus 9x squared minus 30x equals 0. Okay? All 3 terms have a common factor. So I'm going to take out a 3x, and I'm left with x squared minus 3x minus 10 equals 0. This is slightly different because we need this. It is not a constant, right? We have that variable there, so this is very important to carry along here until the end of the problem. So I'm going to just write that here, 3x, and then I'm going to factor the remaining trinomial. And again, since a is 1 here, all I'm doing is thinking of factors of negative 10 that can combine to give us negative 3. That would be negative 5 and positive 2. It's always a good idea still to check to make sure that you have factored this correctly. So we have this completely factored. We're going to set each of our factors equal to 0. And solve. On this first one, we're going to divide by 3. So x equals 0. So that's one of our answers. On the second one, we're going to add 5 to both sides. So x equals 5. And then on the third one, we're going to subtract 2 from both sides. X equals negative 2. So we have all 3 of our answers.